By the end of this video, you'll be able to safely refactor a legacy file using Claude Code, one step at a time, to improve your codebase maintainability and readability. Refactoring legacy code can be daunting, but with Claude, you can break it down into manageable steps. You'll learn how to use Claude Code to identify areas for improvement and then apply targeted refactoring to make your code more efficient and easier to understand. This is crucial because legacy code can be a major hurdle for development teams, slowing down progress and increasing the risk of bugs and errors. By refactoring safely and efficiently, you'll be able to modernize your codebase, reduce technical debt, and make it easier for new team members to get up to speed. We'll take it one step at a time, using real commands and real file names, so you can follow along and apply these techniques to your own projects. To get started, you'll need to have Claude Code set up and a legacy file in mind that you'd like to refactor. Your first step will be to open that file in your code editor and prepare it for refactoring with Claude. Vocabulary: refactor, maintainability, readability, legacy, codebase. By the end of this, you'll have Claude set up for safe refactoring. First, create a new Claude Code project. You can do this by running Claude init in your terminal. This will set up the basic directory structure for your project. Next, create a new file named claude.md in the root of your project. This file will track your progress and serve as a central hub for your refactoring efforts. In claude.md, add a header for your project, including the name and a brief description of what you're trying to accomplish. Now, configure your MCP server to work seamlessly with Claude. Run Claude config to set up your server, and follow the prompts to link your project. Make sure to select the refactoring template when prompted, as this will give you the necessary tools and features to work safely. With your MCP server configured, you're now ready to start refactoring your legacy file. You'll be able to use Claude's features to test, analyze, and improve your code, all while keeping track of your progress in claude.md. Your next step is to link your legacy file to the project, so go ahead and try running Claude Link to get started. Vocabulary: Refactor, Claude.md, MCP, configure. By the end of this step, you'll have a list of areas in your legacy file that are ready to be refactored. We're going to use Claude's code analysis capabilities to identify parts of your code that can be improved for complexity, redundancy, and performance. First, open up your terminal or command prompt where you're running Claude Code. Make sure you have the project with a legacy file you want to refactor already loaded in the IDE. Type this command into Claude Code. Claude analyze, file path / to /your /file.py. Replace path / to /your /file with the actual path to your legacy Python file. For example, if your file is old_code.py and it's located in a folder called legacy, you would type Claude analyze, file /legacy /old_code.py. Hit enter. Claude will scan through your code and provide detailed insights on potential refactoring targets. You'll get reports on complexity, redundancy, performance issues, everything you need to know. Open the report that appears in your terminal or IDE. It might look something like this. Plain text: file /legacy /old_code.py. 123 def complex_function. 124 hashtag this function is overly complex and could be split into smaller functions. 125 126 def redundant_loop code_list. 127 for item in code_list. 128 if item equals example. 129 print this loop checks every element, which can be done with a set. Performance hints: function complex_function could use a docstring and comments to make it clearer. Consider using sets instead of loops for the redundant check on line 128. Areas for improvement: improve code readability by breaking down complex functions into smaller ones. Use more efficient data structures like sets for performance gains. This report highlights specific lines in your code that need attention. For example, complex_function is overly complex and could be split. The loop on line 128 can use a set for better performance. With this information, you now know exactly where to start refactoring. Open up your text editor or IDE And let's begin by addressing the first target, breaking down complex functions into smaller ones. All right, now that we've identified the targets for our refactor, let's dive into some concrete steps to make these changes safely. We'll be using Claude Code and Claude.md to help us refactor a legacy file. The goal is to simplify complex code by extracting functions, simplifying conditionals, and reducing duplication, while ensuring every step is reversible and testable. First up, open your terminal or command prompt and navigate to the directory containing the legacy file you want to refactor. For this example, let's say our file is legacy_logic.py. 1. Start by opening the file with Claude.md. Bash. Code legacy_logic.py. 2. Identify a complex function or piece of logic that can be refactored. Let's assume you've identified a long if-else block in the process_data function. 3. Extract this if-else block into its own function. Python. Hashtag in legacy_logic.py. Find the if-else block and extract it. Def process_special_cases data. If data 0, return negative. If data greater than 100, return large number. Else, return normal. Hashtag replace the original if-else block with a call to this new function. Result equals process_special_cases data. 4. Ask Claude Code for guidance on simplifying conditionals. Plain text. Claude, can you suggest ways to simplify the if-else logic in legacy_logic.py? Claude will likely respond with recommendations like breaking down complex conditions into smaller functions or using more descriptive variable names. 5. Apply the suggested changes. For instance, if Claude suggests introducing a new function. Python. Hashtag add a helper function for special cases. Def is _negative data. Return data 0. Def is _number data. Return data greater than 100. Hashtag update process_special_cases to use these helpers. Def process_special_cases data. If is _negative data. Return negative. Elif is _large number data. Return large number. Else, return normal. Hashtag confirm that this change maintains the original behavior. 6. Run unit tests to ensure everything still works as expected. Bash. Pytest. Verbose legacy_logic.py. 7. Commit your changes with a descriptive message. Bash. Git commit am refactored process_special_cases function in legacy_logic.py. 8. Push the changes to your repository if you're working on a version control project. Bash. Git push origin main. By following these steps, you've safely refactored part of the legacy code while keeping it testable and reversible. All right, you've got a clean, streamlined file thanks to our step-by-step refactor process. Let's take a moment to review what we did and discuss some best practices for iterative refinement, testing, and collaboration using Claude. First off, open your refactored file in your code editor. Take a look at the changes. How do they compare to the legacy version? You should see a more modular structure, right? Perhaps you've split functions into smaller, more focused pieces, or introduced constants where needed. This makes your code easier to read and maintain. Now, let's chat about what made this process so smooth with Claude. First off, its natural language understanding is key. Claude helped us break down complex refactor steps into digestible chunks. Plus, its ability to handle multiple subagents allowed us to tackle different parts of the file simultaneously without getting overwhelmed. For iterative refinement, always keep a safety net in place by running tests frequently. With our current setup using MCP servers and Claude's hooks, you can easily set up test cases that reflect your application's real-world scenarios. This ensures that every change is not just syntactically correct, but also functionally sound. Collaboration with Claude is particularly powerful when working on a team. Use the chat logs feature to keep track of your changes and discussions with Claude or other team members. For instance, if someone suggests an improvement, you can ask Claude to incorporate that into your next iteration. This keeps everyone on the same page and fosters a collaborative environment. Lastly, always document your changes. Claude.md is an excellent tool here. Use it to log your thought process and decisions at each step of the refactoring. This documentation not only helps you remember what was done, but also serves as a valuable resource for future developers who might work on this codebase. By now, you should have a solid understanding of how Claude can streamline your refactoring efforts while maintaining quality through testing and collaboration practices. By now, you should have a good understanding of how to refactor a legacy file safely with Claude Code, ensuring that the process is both efficient and error-free. You've seen the power of Claude's step-by-step approach to break down complex refactoring tasks into manageable chunks. In our previous steps, we reviewed the results of our refactoring efforts and discussed best practices for maintaining clarity and consistency in your codebase. You're now ready to apply this knowledge in a real-world scenario. Let's take it one step further. Pick a small function within one of your legacy files that could benefit from some refinement. Maybe something that has a confusing comment or a piece of code that could be broken down into smaller, more understandable parts. 1. Open the file. Open the specific file you wish to refactor in your editor. 2. Identify the area for improvement. Look for a function or section that stands out as needing improvement. Perhaps it has too many responsibilities or could be split into smaller functions. 3. Prompt Claude Code. Use Claude Code to help you refactor this area with one specific change at a time. Here's an example prompt. I want to refactor the process order function in the order management.js file. Can you help me break down its responsibilities by splitting out the validation logic into a separate function? 4. Review and test. Once Claude suggests new code, review it carefully. Make sure everything still works as expected. Then, run your test to ensure that no functionality has been broken. 5. Commit changes. If all looks good, commit the changes with a descriptive message like refactor process order by splitting validation logic. By making one small change at a time and thoroughly testing after each step, you reduce the risk of introducing bugs or breaking existing functionality. This method ensures that your refactoring efforts are incremental and manageable. Now it's your turn to apply what you've learned. Take a function in one of your legacy projects and start breaking it down into smaller, more understandable parts. Use Claude Code as your sidekick throughout the process. Remember, the key is not to change everything at once, but to focus on making small, high-impact changes that improve the overall quality and maintainability of your codebase. If you're loving this approach or found it challenging, don't hesitate to subscribe for more tips and tricks. We're here to help you build better software one step at a time.